So, you know, I was thinking, wouldn't it be cool if we could figure out how to make it scroll this direction? Like maybe in one of the commands we find, maybe it does. And if it scrolls in this direction, and we can do that fast, we can actually show the ADC in sort of a little graph, you know? Kind of like an oscilloscope, but not really an oscilloscope. But it does show voltage over time. But the scrolling would be going this way, so you'd have time on the bottom, and you'd have voltage in this direction. Oh, cool. So, well, yeah. Well, I want to go through the commands, you know, one by one, kind of like a systematic approach, and kind of learning about the commands and seeing, even though, because, you know, I, as a non-trained engineer. I'm an engineer, but not really an engineer. No, I'm not an engineer. I have some engineering classes that I did in college, but that was related to architecture and it's structural engineering. But then the engineering for this is very esoteric. You know, I don't understand the esoteric language. I'm trying not to say but when I don't say I have a longer period of silence. So, and in my software, I can remove that silence, which is really nice. So I'm going to try not to say the datasheet. So if the datasheet has this language that I don't completely understand, so this is the reason why I like experimenting with these. I said I like to experiment with the specific commands one by one, if that makes sense, and see what they do in reality, which I find exciting. So let's get started. Oh my God, how long have you been not being able to hear me? Oh my God, I'm sorry. Let me add a source here. It is a good link as a source because Adafruit has very good PDFs. They have really well documented PDFs and probably the original. I think that's the most entertaining way to do it too, because you know I want to entertain as much as I can in this, not hyperventilate like I was doing last Wednesday, and trying to fill the space is very difficult. So I'm going to be explaining it in a way that a layman would explain it. I've learned in college you learn a lot of conceptual and fundamental aspects of things in general, whatever subject you're doing. Like in architecture, we didn't really specifics of how a building is built, the conceptual ideas on buildings, but we still had to learn about structures and things like that. So we could still provide for the public health, safety, and welfare. In terms of data sheets and terminology, I'm going to hopefully be a benefit to anybody because of I am live streaming, and also the dogs. Can you keep them quiet, please?
Oh, yeah.
Thanks,
sure.
Appreciate it.
Can I say hi to your live stream?
If you want.
Hello, live stream. Are you live streaming OLED?
Yes, we are live streaming OLED.
STM32?
Yes.
Am I smart for that?
Are you what?
Am I smart for knowing that?
You're smart now. You're probably smarter than 90% of the public, just knowing STM32 and OLED.
Yeah.
Maybe not OLED, because everybody has OLED.
Yeah,
oh, Skeptic says hello. Okay. Hey, MyTech, how's it going? Thank you for coming in. Take a look really quick at the comments. All right, so as I was saying, hopefully this will be a benefit to everybody. Yes, get rid of that headache with some caffeine. Every morning I'll have 2 cups of coffee, and if I feel a slight headache coming on, because my sleeping is erratic, and generally sleeping for me causes headaches, I will have some BC powdered cherry, and that also has caffeine, so I am generally just hopped up on caffeine. So I have 3 jolts of caffeine every morning. Well, not every morning, mostly 2 jolts, but then the BC powder with that caffeine, it's just aspirin and caffeine. It's nice. It gets rid of my headache pretty quickly. Yeah, aspirin is good for you too, so you know, it keeps your blood nice and thin and keeps the heart pumping. Okay, so the one we left off was 0xD3, so that's the display offset, and this one is much more clear to understand as an offset for the position of the OLED, the lines, the 0 to 63 lines. Okay, so let's take a look at the next one. The D3 was the last one. What's the next one? Let's see. And also, you know, all this stuff right here was created by Claude, so what it actually says is probably very close to what the datasheet will say. So this is a fly, and fly is, we can update it on the fly, that we've at least been able to experiment. And then this one has values of, where's the D3? From 0 to 63. So what was I doing? We can actually go farther, I believe, but no, that was the other one, wasn't it? Yeah. So we're going from 1 to 63. We could probably go from 0, but I think it was not really doing much when I changed it to 0. So this is the value, so I'm going to put the values in where the command is. So from 1 to 63, it's most likely going to be from 0 to 63, so I'm going to go ahead and put that. So I'm just going to put offset, or set row offset. And in this case, we've noticed that the 0 is at the bottom and 63 is at the top, which is kind of counterintuitive. If we just started from, like, if we just turned it on, we can see how it starts. Oh wait, no, actually, yeah, because it wrote it in the beginning. So if the initial offset was at 0, right? Yes, it was at 0. So yeah, Bob is saying not counterintuitive. A lot of things start in the bottom left, but it actually, we had the offset at 0. So the offset really isn't it is offsetting by the number of rows, but all it's doing is it's moving it up 1. So if the offset is 1, it moves it up 1. If the offset is 2, it moves it up 2. So I could just write this as moving pixels up. So this, to me, is it explains to me what's going on, rather than trying to understand. Yeah, it's just offsetting. It's taking that line and just moving it all the way up to the top. So 63 would be moving the bottom all the way to the top. Yeah, that makes sense to me. Does that make sense to you guys? Hey Mick, how's it going? Mick Jagger is in the house. Yeah, nice. Can watch now, but can't wait to come back and give it a crack. Yep, absolutely. And watch the previous OLED videos as well. Those will give you a good starting point. Okay, so the next one is set display clock divide ratio oscillator frequency. This one, I'm a little bit hesitant. 80, let's see what 80 is. D5, display clock divide ratio. Okay, so this is going to have a lot to do with probably the I2C communication protocol clock, because right now we're working with 1 megahertz. You can't always get what you want, that's true, but you can try sometimes. All right, so the clock divide ratio. Set the divide ratio to generate DCLK display clock from CLK. The divide ratio is from 1 to 16. This sounds like a prescaler to me, with reset value equals 1. Please refer to the section 8.3 for details relationship of DCLK and CLK. This could be also the base, between the controller and display ratio. We could play with numbers if we want. Let's see, oscillator frequency. So the divide ratio, let's see what values they would provide here in the actual table. D5 here. So this is set. So you can't really change this, but you can change the next value. So set the oscillator frequency, increase with the value of A7:4 and vice versa. Reset is 1, 0, 0. 0B. 0B means that's a binary number. Range is from 0 to 111. No, it's actually, yeah, it's a 4-bit number, 1111. All right, so 0 to F, essentially. And what does that do? What would happen if I actually change it? And what is the default value? So 80 What is 80? So let's check that out. Let's go to our trusty hex to decimal converter here. So let's go 80, 128, which is weird because that's higher than a 4-bit number. That makes no sense. That's the default setting. So what is the default setting? So 80 is 1000. So is it like the most significant bits? Is it left justified here? So I'm wondering if it's left justified. It's an 8-bit number, but this is the range. And the reset is 80 seems like a high number. Does everybody agree? The 4 bits is a nibble, unless middle school computer literacy class. I'm thinking if I put in a binary number, let's go from binary to decimal, hexadecimal, this would be it's 8, not 80. Wouldn't that be the right one? Let's see what happens if we do this. What's the worst that could happen? I always say that. Let's press the play button and see what happens. Did I press the play button? Okay, here we go. Oh, look at that. All right. Well, we're still getting stuff all over the screen. You can't really tell on camera, but it kind of has this scrolling look to it. The camera doesn't have the enough frame rate to really see what's going on, but it's kind of like the CRT when you turn the channel. If you're old enough to know that, like when you turn the channel on from like 4 to 5 or whatever on a VHF, and you kept turning the channel, you'll see that like kind of behavior. That's what it looks like in reality. Oh, it must be a left justified number. I'm going to go back to 80 to bring it back to the way it was, and let's see what happens, because this is the 1 to 16 division for the clock. So what we just did was we essentially made it, because it must be left justified. It doesn't say that. So let's take a look at the explanation. Program the oscillator frequency FOSC, that is the source of the clock, if the clock pin is pulled high. The 4-bit value results in 16 different frequency settings available as shown below. The default setting is 1000. It's not clear on whether it's a left justified, if it's left justified. So if I made this one, yeah, that's 8. So how is this 80 in a default? I could ask Claude about this. The left justified, I'm thinking the bytes or the bits that they're referring to are the most significant bits. The 4 over here, because if I put a 1 here and then put the rest zeros, that would be 80. And they say the reset is 1000, so I'm expecting that to be here, and that would be 8. And we saw what happened when we put 8. Check page 22. All right. Okay, so this is 22 here. Thanks. Let's read this. So this is the internal oscillator divider. This is the number. This is the infamous MUX. This module is an on-chip low-power RC oscillator circuit. So it's a standard RC, which, like the one that comes in the, it's not crystal-based. In other words, the operation clock CLK can be generated either from internal oscillator or external source CL pin. We're using the internal oscillator, I'm assuming. This selection is done by CLS pin. The CLS pin is pulled high, internal oscillator, if chosen, and CL should be left open. Pulling CLS pin low disables internal oscillator, and external clock must be connected to the CL pins for proper operation. When the internal oscillator is selected, its output frequency FOSC can be changed by commands D5H. Right. Okay, so 7/4. This is where it's what it's talking about. This is the bits that it's using. This right here makes a lot of. I have no idea what endin is. Yeah, so that's why it's 80. So it's because of this, right? Am I correct in thinking that? Like the 7:4, because, and this is exactly the way they show it in the data sheet for the reference manual as well. So if I go to, where was it? No, it's down here, right here. So this is the 7th to the 4th, 7th to the 4th. Okay, terms of the art. Yes. Nice. Hey, you guys can teach me while I teach you, but I'm probably not teaching anybody here. All right. So from the 7 to the 4th, that's the number. So let's go ahead and put in a number that is actually just one below the. So we're going to have to. So what would, let's go back to here. What would this be? So right now, this is the 80, right? So if I made this 0 and I went here, this is the number, this would be essentially the first division. Dividing by 1 and divided by 16. So let's see what this would be. This would be 10. So let's see what 10 would do. I'm assuming 10 is going to do the same thing as the other one did. You can't see what I'm showing. Capacitor, welcome. Thank you for coming in. Hey man, I've been stuck on using DMA with DAC for a while. Anybody have any experience with it? Could really use some advice. We are going to get into DMA and DAC eventually, but what I've been doing is, let me put this here. I'm going to add I think it's this one right here. Add existing here too. Yeah, future topics. So future topics, I want to put a little list on the top. Whenever somebody comes up with a future topic, I want to add that topic. Does anybody have I'm going to put it small so it's not going to take over any major real estate here. Anybody have any objections to this? Let's see, yeah, future topics, DMA. So when you mention DAC, do you mean PWM and modifying the duty cycle? Or are you referring to another type of DAC, like an external DAC? Anant, thank you for coming in. Welcome. How you doing? Okay, so I'll take a look at that. We can discover that together in another live stream, but that's going to be probably much later on, unless others have a desire to go into it sooner than that. But I want to try to keep things in this live stream as systematic as possible, so we don't go too far off topic. Right now we're talking about ADC and the OLED, and it's kind of a related, those are two kind of related because I'm going to be showing the ADC on the display, and also in future projects the display will be used quite often, and I'll be using the STM Cube monitor, and I'll be using the STM Studio as well to show data, but we're doing this first so I can use this as an option to show data from from the projects we're going to be doing in the future. So DMA is definitely going to be one of them. Yeah, no problem. So yeah, we'll take a look at that. I don't think this specific microcontroller, the STM32 F030, has it, but like I specified in previous live streams, there is an interest in looking into the ESP32 and other microcontroller SKUs under the STM32 line. So maybe the F4 series, higher M series ARM architectures, and getting into that. So they may have those types of things built in. So what I'll do is, if anybody here has a suggestion on the chip that I could use, as long as it's a 64 pin, I am going to get into making other breakout boards for other packages, and I'll be doing that on live stream as well using KiCad. All right, so enough of that. Let's go back to here. So I want to change this to 10. So let's see what happens when we change it to 10. I have a feeling it's going to be the same thing as what happened with 8. It didn't change. So 10 is essentially equal to 80. So if I change this to, I could just use decimal here. Why am I even trying to use, oh wait, 10 is what? 10 is what in decimal? Oh, decimal's over here, 16. So 16, and what would be 10 to 128? 480. Okay, 480. That would be 1E. No, that's not right. 1, 2, 3, 4. That's why. Okay. F0. So F0 is actually the highest number. So let's try F0. Let's see what would be the extreme. So let's run that. Hopefully I won't blow up my OLED. Nothing. No difference whatsoever. I don't see any other D5s in here like I'm being overwritten. And I don't think that anything in here is going to make a difference. So it didn't make it any slower, any faster. It didn't cause any change in its appearance. Page 28. Yeah, I'm using that. Yeah, I'm using this. So we're on, the command that I'm using right now is this one. So we're just seeing what happens if I change any of this. And I changed it to 1111, which is F0, because we're looking at the 4 last bits, these 4 bits. Nothing changes. I got no change in response. Yeah, I'm going to leave it the way it is. I'm going to leave it, I'm going to keep it at 80. So let's go to the next one. And I'm going to say no change with other values. And I'm going to put in, the values would be, these are the range of values. And this, I'm going to, this will remind me what it, what values I need to change. Obviously, like I come back in a year, and I'm going to say, what did I mean by those X's? Same command can set the FOSC and D. All right. Let's see. So change set pre-charge period. That's the next one. Pre-charge period, or 0x22 based on datasheet. Huh. That's interesting that Claude actually specified this. So let's go take a look at the datasheet and see what D9 does. Oh, you want me to try with 0? Okay, let's try with 0 real quick before we go on. I have a feeling we're going to get to that point where it was just kind of giving that weird scrolling effect, or desync effect, I guess you would call it. All right, let's press the play button and I will show you what's going on the bottom. I do see some change, at least on, I don't see the change on camera, in reality, but I see the change on camera. You can see there's some lines scrolling up a little bit. So there is a difference. Oh, interesting. So the last 3 sets D. So it's used in combination. Okay, all right. I totally overlooked this. +1. Okay, so this is the prescaler. This is like a prescaler. And then this sets the oscillator frequency. So you have to use them in combination. Okay. Huh. Well, we could look at every single value between 0 and 255 and see what happens. I know, on page 22 I saw that, yeah, the calculations. But, it's, to me, it's a little bit like, what is it really? I think it's changing the oscillator value, the oscillator between the controller and the display, rather than having anything to do with the I2C. So I think if, at default, I think it's really meant to pair the display with the controller, unless anybody has any other thoughts to that. So I'm inclined to say that this is an uninteresting value to even look at, and just keeping it at the default value, and potentially looking at, because you could use a different OLED display on this controller, and you may be required to match that display with the controller. Yes. Yeah, I think it's very uninteresting too. So let's go ahead and move on. I'm going to go back to 80, and I'm also going to say uninteresting. Probably relates to driver display compatibility. That's what I'm thinking. So if a different display was put on here, then I'm going to go ahead and play it so I can get... You didn't even see what I was typing there. What did you? I'm going to keep it at this. So all I did is I put this here. Probably relates to driver display compatibility. So just making a note. So the pre-charge period, D9. So now you can't see that little line that's scrolling past. Let's go back to D9, the next one. So this is set. This is the command, and this is the value for that command. So phase 1 period of up to 15 DCLK clocks is invalid entry. 8 resets is equal to 2H. What is the value we're using here? It's F1. So this is going to be from 3 to 0 again, and then 7 to 4. So 2H plus 2H equals what? What is 2H anyway? Actually, what is, let's see what 2H, illegal hex number. 0, you have to put the 0x here? Why is this illegal? Oh, H. F is the, what the hell am I talking about? F is the last one. 2H. 2 hex, I guess. They're talking about, what am I doing? Yeah, convert this. So if we put, it's 22, so it's not the same one. So let's see what F0 is. Or F1 is actually. Yeah, 2H equals 2. Yeah, I'm stupid. I can't believe I did that. All right, hexadecimal to binary. Let's go F1, formula 1. All right, so 11110001. So 22, based on datasheet, 22 is the reset. So F1 would be 111111 and then 0001. So this one would be phase 1 period of up to 15 DCLK clocks is invalid entry. 0 is invalid entry. So phase 1 period of up to 15. So this would be 16. So it's using 16 here, and so 1111 is 16, right? I can swap, yeah. F 15 and a 0 to 6. Yeah, it would just be F. So 15 is, it's a 0 based. So 15 and 1 is here, phase 2 period of up to 15 DCLK. So that would be a 1, and this is a pre-charge period too. So is this happening at the very beginning to charge up the capacitors? Yeah, it's using combinations. Yeah, I'm thinking this is kind of going to be one of those uninteresting ones too, and I'm just going to pass it. I don't understand enough about it anyway, but I still feel this is going to be something that is related to compatibility between the controller and the OLED display, which I will probably never ever need to change in my entire life, because these are always going to be a combination that you're going to buy all together, unless you are going to be putting them together yourself as a manufacturer. But generally, I don't see any engineer on a larger project, even if you're working for LG or whatever, you're not going to be separating these two out, the driver and the display. So unless anybody has any objections to that, I'm going to move on. So I'm going to put the same thing here on the next one. This is just an excuse for me to pass on something I have no idea about. I'd have to do a lot more. Like when I was doing tutorials about PWM, it took me probably a week to figure out PWM and how to explain it using various prescalers and things like that. And I would really have to dig deep to figure all this stuff out from myself. Yeah, let's see if they're even needed. That's a good idea. I want to try both to see if it's already a built-in, if it's a built-in default. Let's see what happens. I like this experiment. This is a nice experiment. All right, I am running it. It is connecting, and it's successfully, okay, no change. I don't even need those. So these are not even needed. So this can simplify the program quite a bit just by taking these things out. And maybe even saving a couple clock cycles if this is a critical application, if you needed to reset this often. So they're not needed. Good comment, Skeptic. Thank you. I keep forgetting to try to comment things out to see if they're even needed. And I was doing that earlier, but I need to keep doing that. Okay, so there are only a few more commands left to look at. So set, this one is a DA, set COM pins hardware configuration. So I would think that this is pretty important, and also a compatibility issue between the driver and the display, because I'm sure that's going to be relating to this set of lines here. And whenever I specify that, whenever I say this set of lines here, meaning this ribbon cable of the data lines 0 to 7, and also the read-write enable, all the VDD, VSS, all those various lines, and probably I don't think there's any clock lines or anything like that, because this is not an external crystal, but that sort of thing. And how the communication, the speed of communication, and also the clocks and everything relate between the driver and the display itself. So Let's go ahead and just take a look at the data sheet and see what this even is. DA is DB. DA, is there a difference between DA and DB maybe? Oh, DB is here. So DA, they don't talk about it? Let me see if there's any, oh, here it is. It's in a different location. Okay, so sequential COM pin configuration, alternative COM pin configuration, disable COM left-right remap. This could be interesting. The only values you can change are these two values here, the D4 and D5. So D4, if it is a 1, it's in reset mode. If it's 0, what is the actual? Let me see what the actual thing is. So it's 40. Let's see what 40 is in binary. It's both 0. So there should be a 1 here. Wait, where's D5? DA. So why isn't there a 1 here? That's weird. Because that has a 1. See? 1. And these are the only two that you should be changing. And those are 0. So 0 is equal to sequential COM configuration. And 0 is reset, disable COM left-right remap. So left-right, would it mirror? Enable COM left-right remap. So let's try a 1 on the A5. Let's try a 1 on A5. So what would happen if we put a 1? This is it's 0 base, so 7, 6, 5. So it would be a 1 here. So let's swap 0, 1, 2, 3, 4, 5, and 6. So this will be 60. So what would happen if we put a so default is 40. Let's put 40 here. So I don't know why they're putting, oh wait, this is DB. Hello, I'm doing the wrong one. Okay, so I gotta look at this again. All right, so what is 12? Let's go back. Swap. 12, convert. Okay, so now why is this one a 1? But the one we have here is number 4. So 0, 1, 2, 3, 4. So 4 is a 1 right here. 4 means reset, alternative COM pin configuration. So this is the default alternative COM pin configuration. What would be the sequential COM pin configuration? So let's try that instead. Let's make this a 0. Let's do that first. Yeah, but what is this? Oh, wait, there is a 1 here. There is a 1 here. So what was that? Okay, yeah, that's default. All right. So this is correct. All right, so let's put a 1, or let's put a 0 here. So I'm going to copy this, swap. Let's put a 0 here. That will be number 2, 0, 2. So 12 is equal to default. So let's make this a 2 and see what happens. I'm running. Well, that's interesting. Everything got big. It's running over each other. So we have instead of 64 lines, we have 32 lines, or it's the way it redraws it. So it maybe even odd. That's interesting though. It's twice as high. It looks like it is. It's really hard to see in camera. Let me try and do a close-up here. But you can see where like some of the pixels aren't even being drawn. So it looks like it's every other line. You see? All right. Stay, camera. Okay. So it looks like it's every other line. Sorry if anybody's getting queasy. So it looks like it's scanning on the odd lines, and then it's scanning on the even lines. That's what it looks like to me. That's kind of interesting. It's almost like, what is that? Interlacing? Remember interlacing in back in the day when you have like GIFs and yeah, interlaced. That was something that we used back in the day for images, I believe. Interlaced images. This looks like that. So you could draw it in 2 passes, which could be kind of an interesting idea if you wanted to have maybe a faster refresh. Yeah, JPG interlacing. This looks like that, doesn't it? All right, I'm going to go a little bit farther back. See if I can get more of the... All right, this is probably a better view here. Okay. All right, stop moving, camera. I need to change my camera jib so it doesn't swing. There's a lot of inertia at one end of it, and I need to make it so it has a more rigid span. All right, let's go back to the default. This is interesting. So what we can do is we can say, oh wait, we didn't try the other the other one either, did we? So we can try a 1 here to see what happens. So this is 0, 1, 2, 3, 4. So we want to change to 5, and we want to put back what we had in 4. So that would be 32, or yeah, hex number 32. So it's always a 2. Always has a 2 there. It's either 1, 0, 2, 1, 2, or 3, 2. So I'm going to press play. That's interesting. It looks like it's a sub 8-bit. Instead of doing it to the whole screen, it does it to each individual 8-bit line. And if you look at it, it has 2 states as it's scrolling up. You know, this scrolling may be causing us to not really see what these things are doing. Although movement is kind of interesting. Let's get rid of this for now. I'm just going to get rid of this because rewriting stuff makes it much more easy to set it in your brain later. So let's go ahead and let's see what happens when I just take out the for loop. Okay, I can't exactly see what's going on, but the T, let's see, look, if we focus on the T, the bottom part of the T goes on the top, although it doesn't really do the same thing with the U, but oh yeah, it kind of, yeah, because the T, you can't really see what's going on in the very middle of it because it has just a line, so you wouldn't really see, but it looks like almost every other line in the 8-bit is swapped. Interesting, but I don't think it's going to be really relevant to what we ever want to do, so I'm going to change it back and not look back. And also, let's see what happens if we just, I'm going to go back to default. If we just take this out, because the default could be just doing that. So let's see what happens. Okay, that's the default. That's interesting. So we need to have, the default is 32. So I'm going to run it again with 12, hex number 12. Okay, so that's interesting. We need that line. And the default is actually 32. So I'm going to put 32 here, and but 0x12 works, period. All right, so now we have another one. It just looks like it's the same, it does the same thing. So this is the alternative COM pin configuration, and then this was the deselect level. And they both are related in some way. So deselect level, and that's down here, dB. Okay, this is, I don't know if I want to change this actually, because this has to do with power. The VCOM-H, which is the 0 to 63, maybe this would have something to do with brightness. We can try the different, we can try 0, 0, 20, and 30. And maybe 1 is like low power too. Let's see, 0, it's 0.65 times VCC. What is the default here? 40, and there is no 40. So what would be 40 anyway? And it doesn't tell you what default is. Let me go to the actual documentation on that one. Oh, this is the explanation on DAH. So sequential, so I guess we are using the sequential, yeah, 0 and 0. Although no, we're not. On one of them we're using non-sequential, and that was the A4 is equal to 1. So we're actually using, yeah, COM output scan direction from 0 to 63, yeah. And scan direction, all right, that's just confusing to look at. Let's go to the other one. Okay, here we go. This is the continuation. We could have looked at this and gotten a little bit more of an idea of it, but you can see where it starts. Okay, so yeah, that makes sense. COM 0 would be in the middle, COM 31 at the top, then COM 32. So it just displays it. So that's, yeah, that's a good intuitive idea of what's going on. 0, 31, 32, 63, 0 to 63, 32 to 63, 32 to 63, row. Okay, so 0, it doesn't say anything here. So this is the different combinations that you can achieve by changing those values, which we got a pretty good sense just by looking at it. All right, so the dB, this command adjusts the VCOM regulator output. I'm not going to change that. I'm afraid to change a regulator output because that is power related, and I don't know what the consequences would be, and I don't think that would be good. So I'm not going to even go there. So I'm keeping that one, and I'm going to, and it's weird how it says VCOM-H deselect level. And what was the description in here? Yeah, it's VCOM H deselect level. Okay, so it's still, it relates to the VCC, so I'm not going to go there. And then we're getting to the end here. If I took this out, what would happen? I'm running it. Nothing. But I'm going to keep it in because I don't know what... I could actually put like a meter on there and see if there's any different draw. But I'm going to keep it this way because when I was metering it before, it was there was no fluctuation in voltage within the entire system. So I'm going to just keep it the way it is. And I could be BSing this whole thing because I have no idea what this actually does. But I'm going to keep it at default. All right, so internal IREF setting. What is the AD? Let's check that one out. Does that even exist? It doesn't exist. What does it say it is? Internal IREF setting. Enable internal IREF. What is IREF? Let's see if it has something in here. And it's a command is AD. Okay, I can't find any reference to AD in the data sheet. Oh, look at this. Horizontal scroll setup, and then vertical and horizontal scroll setup. Continuous vertical and horizontal scroll setup. Interesting. We can try that too. All right, let's see if we have anything else here. Nope, we're at the end. Okay, so I think we're going to leave this one alone. I don't know what it really means. Or let's just take it out and see if it makes any change on the display. Does anybody else understand the AD or has seen anything with the AD in the datasheet? Nope, nothing changed. So since I don't see it in the datasheet, why do I even need it? Or why should I even use it? If it's not in the datasheet, I'm taking it out, unless it has something to do with the I2C stuff. But what I could do is go to Claude and ask Claude and see why it was even using it. And what do? We say thanks, because we're making sure we're ensuring ourselves of potential annihilation or not having that happen. Okay, so those two lines are sending specific commands to the... Let me explain what they mean. You're correct, these specific commands might not be explicitly detailed in some versions of the datasheet. They are actually part of the advanced configuration options for the STM32 controller. The internal reference is related to the current control for the OLED display, so current. Okay, so this is like a VREF, but it's I, because I is current. That's interesting, because that means that we could potentially reduce the current draw on the display. And I'm wondering, because there's no information in the data sheet, what would be the lowest current draw we could enable by this? So I'm going to ask Claude to see if there is a specific number here, because that is really interesting to me. By enabling the internal IREF, you're using the controller's built-in reference current source rather than external one. Okay, yeah. All right, so we're using the internal. These commands are often used to optimize the display's performance and power consumption. However, their exact effects can vary depending on the specific OLED panel and overall system design. So it's a driver to OLED thing. If you're working with a pre-existing library or code, these commands might have been included based on empirical testing or more detailed documentation from the OLED panel manufacturer. If you need more specific information about these commands, might want to check. Look for the most up-to-date SSD 1306 or look for application notes. What does and what other values can I use? And you can't see what I'm saying here. Okay, so 48, the default value is 48 in decimal. 6 bits are used in the reference current value. Okay, other possible values can... lowest current, dimmest display. Okay, let's try it. Let's try 0, 0 to see how dim, because it's pretty bright right now. Let's see if we can dim it. But does it actually specify what would be... Let's see if it actually knows this. What would be the actual current draw at 0x? I don't think it's going to have a response to this or know what it is. All right, let's see what the lowest setting is while it's giving me this answer. So let's go with 0 and see if I get a dim display. I did see a difference, and I see a difference visually. I'm going to put this in the for loop, or at least I'm going to put it in the while loop and see and change between the two with a delay. So I'll start with 30 and I'll go back between 30 and 0. And I'll use 200. Yeah, I'll use 200. 200 is good actually. So let's see what happens. So every 0.2 seconds we should see I don't see any difference. I do see, well actually I see it. Yeah, I see it in reality, but on the camera it's very difficult to see it. I'm gonna see if I can out of focus it, and you can probably see, no, you can't really see it on camera. But it is definitely going back and forth with a bright, dim, bright, dim, bright, dim, and looking at it with my own eyes. So I don't see much of a reason why I shouldn't put it in the dim mode, because it's already still pretty bright. So I'm going to go to dim, keep it at 0. So I'm going to specify here, changes. All right. Okay, so charge pump setting, 8D. I don't think that was in here either. I think we're pretty much at the end. We can look at some other ideas, but I still didn't get to anything that had oh yeah, we could look at the horizontal and vertical scrolling. So we can go to that next to see if I can actually enable that or figure that out. So 8D, I don't think the 8D is there. No, I don't see 8D. Hey CNC, how's it going? Thank you for coming in. We have pretty much gotten to the end of the command. So at this point, I was kind of interested in seeing if we can get a horizontal scroll, because we've gotten the vertical scroll, but there's no command for horizontal scroll, and there is something in the datasheet though for that. So I'm going to be playing with that and see how that works. So this is the horizontal scroll setup, and that's 26H and 27H, and I thought we went through that somewhere around here. No, I don't see a 26H and 27H here. So we can try that. All right, but I want, now I'm not going to get into this. The AF is just display on, so we know what that is, obviously. It turns it on. I'm going to take out I already did that. So I'm going to go ahead and play and put it back into the the dimmest mode, which is still pretty bright. Okay, now you can actually see on camera that it's not doing much of a fluctuation between dim and bright. So let's take a look at the horizontal scroll. So horizontal scroll setup is 26H and 27H. First, I want to see if there is a 26H and 27H here in the documentation up here. I feel like I saw it somewhere. No. Okay, so we'll go back down here and see how we can invoke it. So this command consists of consecutive bytes to set up the horizontal scroll parameters and determines the scrolling start page, end page, and scrolling speed. Nice, that's interesting. Before issuing this command, the horizontal scroll must be deactivated. 2EH. Are we using 2EH? And does 2EH deactivate it? So 2E, do we see a 2E here? I don't see a 2E, so we need to do that. We actually need to create a command that says that. So the RAM content may be corrupted. So we need to do this first, and then we'll set up the 26 or 27. So I don't know if this is just a command you just put in, so let's try that. 2EH, I'll do it at the end, right before the display on. 2E, so let's see what happens. I'm just going to put the 2E first, just to see what happens. Take this out, because I don't know really what this does yet. Check table 2 for scrolling commands. The blue pill, the blue one. All right, let's see. Where is table 2? Yeah, table 2. Table 2. Would it be under the section 2? What page is table 2? Wait, there should be tables here. Table 2, table 2, table 2. No, table 2! Oh wait, here we go. Page 28, okay, thank you. Oh, here we go. Wait, no, this is not it. Okay, 26 and 27. Yeah, all right, cool. So because it wasn't in the command set that was provided by Claude, we are looking at things that are sort of outside of that command set that was sort of defaulting everything for the minimum setup. So now we get to the stuff that the datasheet can provide us. Okay, so 26 and 27, this is the horizontal scroll. Right horizontal scroll, so that would be the 26H. left horizontal scroll, which is 27H. So let's go ahead and do that. Let's try the 26H first. So this would be, we're changing this command, and then this relates to that. So we have four commands after that, or 4 values that we have to set up. But what would happen if we didn't put anything here? What if everything is 0? No, wait. 1, 2, 3, 4, 5, 6. Okay, there's 6. Horizontal scroll by 1 column. So the column is, there's 128 columns. Define start page address. If I keep all of this, okay, we can change by number of frames. That's interesting. I'll bet you there's defaults here. Like if I just kept it at 0, let's see, would be 5 frames is just 0. It's page 0, and 0 is page 0. So let's see what would happen if we just put in the command. Let's start with that. So 26, pressing play, and I got nothing. All right. So I do need to have those other commands below. So let's see. I'm going to keep this interesting, see if Claude can help me on this. Let's see if it's able to do something here. Okay, so dummy byte would be 0, start page 0, time interval 5 frames, end page is 7, assuming full display, scroll, dummy byte, activate scrolling. So let's try it. So that's 26. So, and then we can get a more intuitive idea after I put in all of these. All right, it said it needed to do this first, so I'm hoping that is correct. Let's see what happens. Okay, so all 0, Skeptic says all 0, and then the last one. Okay, here we go. Well, that's not exactly what I want. But let's reset that and see. Huh, it's not doing it now. I just reset it. Weird. It's weird that I reset it and it didn't work. Let's try it again. That's very, very odd. It's not working anymore. Wait. Yeah, and it definitely downloaded correctly. All right, I'm going to do 0, 0 all the way down and just the FF at the end. So this is activating the scrolling, the 2F. I'm going to do what Skeptic said. So far, it hasn't had a mind of its own, but now we're seeing it does. That is very strange, isn't it? Okay, so this was 7. 2E is the, I guess the, oh, okay. What, AE? No, wait. What is AE and AF? Oh, that's display on and off. This was 7, or was it 6? I'll just Control Z. Yeah, 7. Adams, welcome. This reminds me of the earliest days of programming a Commodore PET. Yeah. Output port fiddling. 5 bytes. 5 bytes or 5 frames? Are you talking about the 5 frames? Start page 0. I'm guessing the 2E starts the assumption that we're going to be going into that. Oh, wait. I'm not. Oh, wait. Hold on a second. I don't have the 2.6. Yeah, I don't have the 2.6 here. That's why. But I don't know why it would work once and then not work before. Maybe because I had it in the previous program. What did Claude say? Yeah, no, I copied it, but it's not there anymore. Huh. I copied it and then I pasted it. Let me see if I paste down here if it's... Oh, crap. No. I overwrote my clipboard. All right, let's try it again. I don't know why that didn't get in there. The ghost in my clipboard. Okay, still it doesn't work. What did I change? Let me, do I want to do it after the display is on, maybe? Let me just go back and, this is what I had before. Let me go ahead and play this. So, Skeptic, you're saying 6. Why should I be, oh, what the hell? I didn't put in anything. Look, it's not supposed to do this. After the command 6 bytes. Okay, right. 1, 2, 3, 4, 5, 6. Okay, all right. But still, why is it doing this? Could it have something to do with me not doing this? Let me put these back in. I know I make a change and I'm not really doing it correctly. DIY code. Oh yeah, that was part of the statement I was making. Why do I expect the message to come up on the alien's computer screen for Independence Day? Yeah, right. I'm deciphering that message from the aliens in contact. Okay, let's run it again because maybe it needs to be reset. If I run it again and it still does this, that's going to be weird. Oh my God, no. Why is it doing this? Every time I run it, something new appears on the screen. I'm running it again. Okay. Maybe. Well, I'm going to turn it off. I'm going to actually disconnect it for a little while. Let the capacitors drain. That should be good enough. Okay, there you go. All right, there was a state that was remaining in the display itself, so I wasn't resetting it completely. So let's go back. Let's continue and try it again. But I'm going to use. All right, so this is 1, 2, 3, 4, 5, 6, and then 7. Activate the scrolling. So that's the activation. Get away. All right. So let's try it again, but this time I'm going to unplug it completely. I need the 2E, and then the 2F invokes it. Take this out. Okay, so this should work. But it's weird that it doesn't like do a reset. So after I run it, I'm running it right now. After I run it, I'm going to reset it. All right, so I'm going to reset it now. Take power completely away from it, replug it in. Okay. Looks like we have a pretty good horizontal scrolling. So let's play with the horizontal scrolling and see what happens with these various values, like the dummy byte, start page 0, the time interval, assuming full display scroll, page 7, end page equals 7. So what does that all mean? End page, what is that? Well, let's start with the first one. That's the start page. And page is equal to, let's go back to the full description of it. So you're talking about like the 128 pages, you think? So each page is 128 pages. Let's go look at the, yeah, so seg 0 to seg 127. Yeah, so 128. Good. These are segments, page 0 to page 7. So what does the page 0 and page 7 mean? Well, we can change it. We can change it and see what happens. And it doesn't have page here. Okay, so the 2AE deactivates the scroll, and 2F activates the scroll. So we got that. All right, let's go back to the description of, oh wait, here, what is this? Page. These are columns, and this is memory addressing. So I'm trying to figure out what page means. Skeptic says lines in your language. Okay, lines in the, okay, yeah. All right, lines in the character. So the 8x5, so, oh, this is page 2. So segments, comms, starting page 0 through 7. So the entire screen. Oh, I think I know what it is. Right, okay. Skeptic, you see the yellow lines are page 0 and page 1. So you're not allowing certain parts of the display to scroll. So only, like, if you wanted to have the top 2 lines static and the rest of them scrolling, we could do that. So let's try that. At least that's what I'm understanding. So let's start at end page 7, start page 0. Let's start at page, what value do I put in here? For if I want to start at page 2, where was it? Okay, so page 1, page 2. Okay, so this right here. So what is 0, 1, 0? And B, it's these 3 here. So it's okay, that's going to be very, very easy. So the binary is 0, 1, 0, convert, 2. So that's easy. 2. Start page 2. All right, let's see if that works. Let's play. I'm probably going to have to reset it again. There we go. Yeah, very cool. So we could have some kind of description here, a static description, and then whatever is happening down here, we can have it scrolling. Let's see if we can scroll it to the other direction, like going the opposite way. All right, so 229, vertical and right horizontal scroll. Okay, so that's 29, 20. 2A is vertical and left horizontal scroll. So let's do 2A instead of 29. Wait, that's 26. What am I doing? Let's go back down. So 27, what is 27? Okay, so this is the horizontal and vertical scroll setup. So we can change it from, this is I guess the direction, right? Okay, let's try changing to, I'm gonna do what Skeptic says, try changing it from 26 to 27. I didn't need to reset it that time though, which is nice. Oh, there you go. Well, I think I do need to reset it though. We got some artifacts going on here. Skeptic, you're right, still got artifacts. Weird. Huh, okay. I needed to turn it off for a longer period of time, I guess. So we got it to work. So we can do, I don't know if we can do this on the fly, can we? Can we change on the fly? Can we make it torque? So 26, And then 27, we'll put a delay in between. Ugh, come on. Delay, milliseconds, 200. 200 seems to be a pretty good value to still be able to see it. So I'm hoping no artifacts are going to happen. I'm hoping we can change this on the fly. I still see some artifacts though. Oh, look at that. It's twerking. I knew it was going to twerk. Let's reduce this number here. We got display torque. Let's go with 100. Oh, we got artifacts. I'm going to turn it off for a little while. I've just unplugged the, I believe the positive. I'm going to plug it back in. Okay. Still, I got some weird artifacts going on there. But once we have it set, it seems to be good. And it could be related to the capacitor I have here too, but I don't think so. It shouldn't take that long for it to bleed. Yeah, that's something odd is going on there. You can see this artifact here. So the horizontal scrolling isn't as smooth in operation. Okay, that looks good. Well, no, still not. Yeah, I'm not gonna get this to be right. It could be the fact that I'm trying to do this in the while loop too, and maybe something needs to be like maybe I need to turn the display off and then on again. I can try that. So display off, and then turn it on for each one. I think. Yeah, I can also increase the delay as well. Let's see what this does first. You see when it keeps the last state. Oh, look at that. Interesting. Yeah, that's not good. But at least it gives me the entire, there's no artifacts, which is kind of interesting. So maybe I turn the display off before the while loop, or I turn it off and then on in the right before the while loop. Yeah, it can't cope with the speed. Yeah, I'm going to also slow it down as well. I'll go 300. But I want to see what happens if I turn it off and on, off then on, just before it goes into the while loop. And hopefully I won't lose any of this RAM. I shouldn't though, because I'm doing it within the while loop anyway. I'm running it now. Okay, that's better. And I didn't get any artifacts. So displaying off and then display on seems to help. I'm going to try resetting it manually to see, because that's when I was getting most of the artifacts. Yeah, no. Yeah, it's unpredictable. I'm going to try to do another flash. Yeah, see, it works when I reflash it. I guess it gives it enough time to, I could put a delay just before it does this as well. Like maybe a whole second of a delay. Let's run. And then let me see if I can reset it manually. Oh, look at that. It didn't even work when I flashed it. So this is just an unpredictable, yeah. It's just unpredictable. So if I'm going to do it, I'm going to have to do it manually probably. Well, let's play with some of these settings anyway, but let's play with them in the command area. Where was that? Okay, it was over here. So let's change this 5 frames to, what were the values that I could use? Here we go. All right, so 5 frames or 3 frames. Let's try 3 frames. So 1, 0, 0, and this is C 2 to 0. Okay, so 2 to 0. So let's try 3 frames. So that should make it a little faster, right? Oh no, there's 2 frames over here. Let's try 2 frames. Let's see, that should be the fastest. 111. What is 111? Anybody know? Before I find out. 7. You're right. All right, let's change it to 7. Oh wait, I want, yeah, 07. By resetting the microcontroller, I'm unplugging the positive. Yeah, it's a little bit faster. So 5 is just a little bit slower than the 2 frames, obviously. So if I go all the way up to 64, and by the way, when I do a reset that I'm talking about, I should be adding a button to this to reset it, but I don't like button to bounce anyway. I'm just taking this out and putting it back in. It's not the best way to do it, but you can see what happens when I do that. So we got artifacts. All right, let's change it to 64. So this is kind of messing things up. Maybe I do a delay after the 2E. Maybe it needs a delay after to get it going or setting up. I can also ask Claude about this. I'm not going to suggest anything. I'm just going to see what it says. Okay, so it's not being initialized properly. Yeah, it's going to give me the entire set of commands, and we've already gone through all of that, so I don't think that's going to be. Maybe I should clear first? No. Right 0 to all pixels. Yeah, I already have a clear and I've cleared it, so that's not going to do anything. Okay, adding delay to certain points in the horizontal scrolling code can be beneficial. So my intuition was correct. So I'm going to delay 10. Okay, I'll delay 10, or is this 10 milliseconds, or is it? It doesn't actually say. So what's the? It doesn't say what the what it is, but I'll just do 10 milliseconds. So we'll do 10 here and do 10 here. So let's see if this helps. Removing the power from both, there shouldn't be any. There's no circuit if I just do one of them. So that, unless it's getting some power from the SWDIO and SWCLK pins, I don't see why I need to do that, but I can do that for sure. And it still looks like there's. I'm going to go ahead and take both of them out. I'll give a better view of this as I do it. It's a little harder to see what's going on the screen though. Yeah, so doing both and doing one are essentially the same thing. That looks a little bit better, but still there's artifacts. Maybe there's no artifact and that's supposed to be there? I don't think so though. Okay, all right, so let's try 64 frames and we'll have totally beat this thing to death. So 64 frames, 128 frames, that would be the slowest. So 010. Who can tell me what 010 is before I find out? 2. Nice. 2 in hex. All right, this is going to be super slow. I'm going to increase this just slightly by 100 by 10 times. So instead of 10 milliseconds, it's 100 milliseconds. Oh, we should put 128 frames. But I don't think I'm going to do the horizontal scrolling anymore, unless, yeah, this is really slow. Unless what I do is, because I will need to find out how to update the rightmost column as I do I could, like, if I'm going to do a horizontal scroll, I will want to update this last line every single time with a new value. Yeah, if it's working after programming, it should work after a reset. You're right about that. Because it does a reset during the programming during the flashing. So that is, I could put a reset button on here, but that wouldn't help me in a real world circuit because I would have to manually add a reset in software, because if this is going to go into a real world circuit, I can't just show code I can't just reprogram obviously every single time. So I would have to do some kind of reset through software. But I'm not really going to explore that yet, I don't think, unless I have any problems later on. An RC circuit would take care of reset. Okay, yeah. Okay, so if I put the RC in the circuit, then I can, you're talking about resistor capacitor circuit, an RC circuit. Yeah, so I could probably do that if I was going to put this in a real world circuit. Okay, yeah, and yeah, if I got to that point, or if I required that, then I would do that for sure. Okay, so what's next? We've gone through all the commands, so I guess we could look at the remaining code. My board doesn't have that specifically, no. My board is very minimal. I don't even have the reset button or pin connected to anything, so I'm not using it in reset mode at all. So you can see it's just the chip, 2 programming lines right here, power, and all the pins that require power are taken to the power rails. That's it. And on the OLED circuit, it's there's a 0.1 UF and a 100 NF, or 100 UF capacitors, just to help the circuit filter anything because of this very offending breadboard setup I have. What's the problem? Oh, because I don't have a reset? Yeah. And I could probably set that up maybe next time. Maybe I'll do a reset circuit on the next live stream. Okay, cool. Yeah. Skeptic says you can connect the reset pin to a reset circuit. That will ensure it resets every time you power it up. So what I'll do is I'll look up how to do that, or maybe I'll explore that in the next live stream. I'll do that from scratch, and because I don't know how to do it. So why not do that on a live stream and learn as I learn, you guys can learn with me. And if you already know it, I apologize for wasting your time, but hopefully you'll still be here and seeing how I do that and maybe helping me along the way if you want to. So with that, it is 3:15 here in Tampa, Florida, and it is my time to sign off. I really appreciate and I'm grateful for everybody that came by and watched the live stream. And I think we're pretty much done with the OLED command set. I will go in and look at the rest of the code, talk about the rest of the code that Claude provided, including how it creates a pixel and various shapes. But that I think that's going to go all in one live stream. So I don't waste too much time with that stuff, because all it's really doing is it's putting a single bit, a 1 in one of 8 pages in this case, or no, not pages, but lines and columns of a character. So we can just go over that, and once we're done with that, I'm going to continue back on the ADC and play with that with the display. So show the ADC values on the display. So with that, thank you very much for coming in, and I am signing off.